Saxon Advanced Mathematics, Lesson 52. We're in Trigland today, and we're going to do a problem that isn't difficult mathematically, but it is a little bit of a mind bender, and it's got some weird words in it. So buckle in and just know that the math isn't hard, and we only have 2 examples. Like I said, we just have to kind of wrap our heads around a weird idea. Let's dive in with a problem. And like I said, there are only 2, so that's good news. And what we're given is we're asked to solve a trig equation, and it looks like this. Okay, it looks kind of harmless, but here's the part that's weird. Go away, little cap, I don't need you. Here's the part that's weird. We have a 3 standing next to our theta. That's a little different than what we've done before. This is a coefficient in our argument. Okay, that is the news flash here. We have a coefficient in our argument. Argument is a word that means something very different in regular English. The argument is just kind of like the value of that function, right? This is the argument. Okay, and there's a coefficient in there. That is going to affect our answer. And I'm going to tell you how, but then I'll show you how it works too. All right? What it's going to do is it's going to, because our coefficient is greater than 1, right? It's a 3. That means we're going to have extra spins. And I'll tell you what I mean later by that. That sounds weird. All right? And we're also going to do one problem where the coefficient is greater than 1, and then we're going to do a problem where the coefficient is less than 1. When the coefficient is greater than 1, we have extra spins. The other part of this problem that I didn't write down yet is our usual limitation is that theta is greater than 0 and less than 360. Greater than or equal to 0. This just makes us happy, right? That just means we don't have to spin forever. But then we see this coefficient and go, oh, that is going to require some extra spins. So I'll get to that later. We'll talk about it more. Now, let's do some algebra just to clean this up. I know I've written all this in here, but just pretend I didn't. We'll add 1 to both sides. And we'll get that the tangent of 3 theta equals 1, right? Because these cancel. Okay, beautiful. Now, some students might look at this and go, hey, let's divide out that 3, okay? We can't divide by 3. And the reason why is another fancy expression. It's called the inviolable argument. And it's an overriding principle in trig. This argument that I've talked about, the value of the function, you can't do algebra to that. We can't divide it or do the things that we normally would do to different terms in our equations. We can't mess around with that. That is connected to the theta, and we can't operate upon it with the usual rules of algebra. So we kind of have to leave it around because it's tempting to say, oh, let's divide by 3, right? No, we can't do that. We have to leave it as is and deal with it in another way, which I'll be showing you. Now, so that's called the inviolable argument. That's the overall principle that we cannot monkey with that 3. What we can do, though, is we can put that over a 1 because we know that with our trig functions, we want to see fractions, right? Now, we also know that tangent is over Arthur, right? So what that means is that we're looking for angles where the opposite side and the adjacent side are the same. So they would reduce to 1 over 1, right? So I grab my unit circle and I just browse around here and think, okay, I'm looking for if opposite and adjacent are the same, that means that sine over cosine is going to be the same. And that means I need the same value. So look, there's one right there at 45 degrees, isn't there? 45 degrees is going to be one great stopping place for, again, it's the tangent of 3 times theta, right? But I told you that because our coefficient is greater than 1, it's going to require extra spins. I'll explain. You'll see later that this is still going to abide by this. But right now, what we need to do, and I'm going to draw a little picture of it. This is on your unit circle, but I want to draw a picture just to help you see. So here is our 45 degree angle, right? And we know that that's going to give us a 45 degree angle, is going to give us the 1/1 values for tangent that we want. And that's cool. So we've got 45 on our list. But here's the thing. We want to take into account one extra spin. And that would be 405, right? I'd add 360 to that. And you'll see why we need that value in a few minutes. But for now, just trust me. And then I want to do one more extra spin. Ready? So it starts here, and it goes around once, and then it goes around twice. So that is going to be 720 plus the 45. So that's going to be 765. Okay? Now, how did I know to go around 2 extra times? In a few minutes, I'm going to show you another way to find out. But one way to know is, oops. In the situation where the coefficient is greater than 1, we have extra spins. The number of extra spins equals the coefficient minus 1. So I took my original value as 45, then I did 2 extra spins because 3 minus 1 is 2. All right, so this is very helpful. Like I said, there's another way I can prove that this is right, but I can't prove yet, all right? So we figured out one angle that satisfies this condition. We took some extra spins because of that coefficient. We'll see how that works out in just a minute. Now we're ready to look and see, are there any other angles that would give us a tangent equal to 1? Are there any other angles where cosine and sine are equal to each other, is another way of saying it. And we know, well, yeah, it's going to be, okay, so we got this one, the 45 degree angle, because they're the same. We look at the 45 degree angle over here, and we see, well, one's positive and one's negative. So that's going to turn out to be -1, and we have +1. So instead, we go down here. These two are both negative, so that'll cancel. So that will give us the +1 value that we're looking for. So we want to include 225 as another option of solutions for us, okay? And just like last time, we want 225, then we want to have one extra spin, which we would add 360 to this, right? So it would be what, 585? And then we want to have a second extra spin, and so that works out to 945, right? 720 plus this, 360. I got this by adding this plus 360. I got this by adding this plus 720, or this plus 360 is another way to do it, okay? So these are the values for 3 times theta, right? Now what we have to do is simplify, because we want the answers for just plain theta. So let me copy these onto the top of the next page. And what I'm going to do is write them I don't want to squish. Those were the first three. Those were the ones where we had positive or positive. And then I'll go down here. And then this is the one where we had negative over negative, 225. No, not 405. It was, I add 360, it's 585. I was copying that number and that wasn't right. And then the last number is 720 plus this, so it's 945. Okay, so that was just me copying what we got for our answers last time. This, let me write this again because we're going to need this in a minute. Okay, this is 3 theta. 3 theta. So what we need to do to get the actual answers to our problem is we need to divide each of these values by 3. And then we get that theta equals 45 divided by 3 is 15. And let's see, this would be you can do just the little calculations over to the side. 405 divided by 3. $135. And then this one should be $225. Right? Those are the actual values for theta. And notice that these all fall within this range. If we had taken one more extra spin, right? If we had added 360 to this and gone a 4th time around, and then we divided it by 3, that number would be out of bounds. That number would be larger than 360. So if you're ever doing this and you accidentally go around an extra time and don't catch your mistake, when you get to this point and you divide it out by 3, you'll see that that number no longer fits within this range. And so you realize, oh, I actually went too far. Okay? So you can take a preemptive strike by remembering how to calculate the number of extra spins, but you can check yourself up here if you ever get an answer for just plain theta that's greater than 360, then you know you've gone too far. Notice that this limit that we were given at the beginning of the problem, it does not say 3 theta has to be between 0 and 360. It says plain theta. That's why we take the extra spins, because once we divide by 3, or whatever the coefficient is, we're going to have smaller numbers, and we'll be able to fit more of them in that range. All right? All right, so that's half of our answer. And then the other half of our answer comes from this other angle, and we'll divide all of these by 3, and we'll get theta equals 75 degrees, 195 degrees. All of this math should check out. And the biggest one is 315. Again, if we had gone around a 4th time, if we'd taken an extra spin, the number for the 4th spin would have gone out of bounds. If we've got the right number of spins, then we always stay within these bounds, all right? So that is our final answer. John sometimes writes this so that all the answers are mingled in together like this. He would jump back and forth between the 2 angles. Right? And he puts them all into nice chronological order. I'm not mad about that, but I actually like it better when you show me, okay, here's one angle and the variations on that. Here's another angle and the variations on that. I kind of like this. I think that this helps me see that you understand what you're doing a little bit better. This is obviously, I mean, you can't fake that. So obviously you get that too, but I'm not at all mad about an answer that keeps the different angles separate. Okay, so this situation was where our argument had a coefficient greater than 1. Our second and only other problem in this lesson I guess there is a third one. All right, let's do 52 point. Oh no, this is right. Sorry, I don't know what I was thinking. There is just one more problem and we're doing it right now. In this problem, we're being asked to solve same limit. This time it's a cosine problem. That doesn't change anything. But look at our argument here. This time, we still have a coefficient in our argument, right? We can see it as 1/2 times theta, right? It's just squished together. This is also going to change the number of answers. Where our coefficient is greater than 1, it gives us extra spins. When our coefficient is less than 1, sorry, I want to write it the same way. We will have fewer spins. Just like last time, we'll be able to figure out why. We'll have a little formula, but I don't want to worry about that yet. I just want to show you how that works. Okay, so here's another coefficient in our argument. And this time it's going to produce fewer solutions because it'll have fewer spins. Okay, first thing we'll do is clean up our algebra just like we did last time. Again, I have a big gap. And we get the cosine of theta over 2 equals minus square root of 3 over 2. We cannot do anything to this. This is the inviolable argument, right? So all we can do now is figure out what angles will give us this, and then we'll adjust our theta at the end, just like we did last time. So we remember cosine is Oscar head Ahold, right? So we go to our chart and we're looking for cosines that are -3 over square root of 2. Okay, well here I see in the first quadrant cosine, which is first, square root of 3 over 2. So that tells me that it's going to be the family of 30-degree angles that I want to look at, orange on my chart. That's why it really helps if you do these color-coded. All right, so here's one right here. A 150-degree angle will give me a cosine of that, which is exactly here. So that tells me that theta over 2 is equal to, it can be 150 degrees. Or, let's keep looking. It could also be, here's the orange family. Here's a -3 square root of 2 in the cosine space. So it could be 210, right? If we go over to this family, we see, oh, here it's positive again, so we don't want that. Okay, so here are our two angles. Now, let me tell you about the limitations when we have a coefficient that's less than 1. The number of fewer spins that we will take is equal to the number in the denominator in the argument minus 1. So in this case, we're only going to have one angle that serves properly as our solution. I'll explain to you why in just a minute. This is, though, the little formula or check you can put on yourself. And honestly, right now this probably feels like something you need to memorize. You'll figure it out, you'll remember, all right? So this 2 in the denominator of the argument tells me that the solutions are, there's only gonna be one solution. I found 2 of them by looking through the whole unit circle. But once I adjust for the fact that there's a fraction in our argument, you'll see that it's going to have to be changed. Let me turn the page. I'm going to copy this and this. So we said that theta over 2 can equal 150 degrees, whoops, or 210 degrees. We also know that theta needs to be between 0 and 360. All right, that's always true. We've got two solutions here because here's the thing. When I look at the unit circle, I'm always going to look at the whole unit circle. If I need to subtract out some solutions, I'll do that later. But I want to consider the whole circle at first. Just like when the number is greater than 1, I consider the whole circle and then I do my extra spins. Okay, so if theta divided by 2 are these numbers, then theta itself, without the fraction, would be twice this, right? 300 and 420, right? We just use algebra here to adjust those values. But this is too big. This falls outside of the range of acceptable solutions. So this is the place at where I can catch myself to make sure that I'm following the rule that denominator minus 1, so 2 minus 1, I'll only have one solution. Here I am catching that this one doesn't work. So our final answer is just theta equals 300 degrees. That's it. All right. These problems are a bit much. Like I said, the math isn't hard, but it is a little mentally taxing to see how when we throw coefficients into the argument, it changes the number of acceptable solutions. That's the bottom line. And I'm giving you some little tips and tricks to figure out how many more or fewer solutions we have, how to catch them if you don't do them the first time. I hope it makes sense. I wish I could see your faces right now. You're either staring out the window because you're sick of listening to me, or your eyes all rolled back into your head. You might even have fallen out of your chair and be comatose on the floor, because this is a lot. I am not kidding when I say that. I mean, you know that. So go do something to relax your brain. Come back to your homework later, and please reach out to me if this seems completely ridiculous. I mean, it kind of does, but okay, thank you. Goodbye.